So my name is Ausmarton Fernandes, and I'm working as a technical lead at PTC. Yeah, so I mean, I haven't really worked with Ruby a lot, but yeah, I mean, this is just one of the things which I like doing, like, exploring vulnerabilities and, looking into security issues and all. And Metasploit happens to be written in Ruby, and it's supposed to be the largest Ruby project so far. So my talk is about, I'm not really going to talk about the whole framework. There's not enough time for it, but then I'm just going to concentrate on writing exploits using Ruby. And that too, I'm just going to look at one exploit, which we'll have a look at a little later. So how many of y'all have, know any of these, things? Like, I just want to get an idea of what kind of audience I'm looking at. So, at least if you all know what these things mean, it'll be, that's what I'm looking at. Okay, okay, so I'll just run over it quickly. So a vulnerability is something which is, it could be because of a bug or a defect in the software or the system, which exposes certain features of the system which you're not supposed to have access to. And yeah, next one is an exploit, which you would have. It's possible because you have a vulnerability. A vulnerability will allow you to execute an exploit. So basically, you're exploiting the vulnerability which is exposed by a particular defect or bug. A payload is basically some code or some data that you send along with your exploit, which is not really the main, which doesn't really contribute to the exploit in any way, but after the exploit is done executing, your payload comes into picture, and it starts, you can do lots of things with it. Now, shellcode is basically a type of payload which allows you to connect to a system remotely. It's basically like exposing a shell, like your bash shell or the command line tools that you use in Windows as well. So yeah, code injection again is like when you embed some code into, it could be two different types of code, like SQL injection is one common example of it. So it's, the code has been written in such a way that when, the outer code, the wrapper code doesn't really have got anything to do with the inner code, but then once the outer code executes, this one, it's usually possible when you have different types of systems. Like in case of SQL injection, you would normally have some SQL embedded into your HTML, which you send over to the server, web server, and from where it can get executed. So these are possible because of vulnerabilities. This is the structure of the Metasploit framework. Now, if you see, like the center of this whole framework is the Metasploit. MSF stands for Metasploit Framework. So the MSF core, which contains all the utilities which you basic utilities and all that defines your Metasploit framework, which is like all the exploits utilities that you need for your exploits and things like that. Base is a wrapper around it, which just allows. So core doesn't really give you much functionality by itself. It just provides you these utilities. Base is a wrapper around it, which gives you more functional features to deal with. And if you see right on top, we have the Rex library. It stands for Ruby Extension Library. So this provides some, we'll have a look at it a little later. It provides some utilities, low-level utilities and all, which you could use, and even some high-level utilities as well. if you see, there are some modules at the bottom, which we are going to look at mostly exploits and a little bit of payloads. So payloads and exploits we have already had a look at. I mean, I already mentioned about it. Encoders are basically something which I mean they allow you utilities to do basic encoding, XOR encoding and stuff like that. No ops for certain places where you need to provide some kind of a padding between your exploit and the payload and things like that. The last one, auxiliary modules. Auxiliary modules are like you could say they are kind of exploits only, but then they could be used for other purposes as well. Like, I mean, to scan your, you guys might have heard about Nmap and other port scanning tools. So, so there is port scanning available in Metasploit as well, and that goes into auxiliary modules, because you don't really exploit a system with that, but then you kind of gather some information about what ports are open and what you can exploit and things like that. We see on the at the end you see some interfaces and also it provides you some command line utilities and consoles to work with the framework, and that's about it. I mean, the plugins are basically, okay, the difference between plugins and modules is when you want to write a new exploit, it will go as a module, and plugin is something which extends the Metasploit framework itself. If you want to provide new commands or new options to existing commands and things like that. So yeah. These are the interfaces. We'll have a look at the first two. The last one is, I mean, it's not really an interface, but then it gives you, it's more of a payload actually. So MSF CLI is the command line interface in Metasploit. So yeah. So when you install Metasploit, it comes with its own bundle version of Ruby. And the installer that is provided by default installs it in /opt Metasploit apps, and inside that it has various this thing like directories. So what we are looking at is the Metasploit Framework 3, and it provides these tools like MSF CLI, MSF console. So these are command line tools which you can use to interact with your Metasploit framework. So if you see MSF CLI, it gives you certain options to check the existing exploits, and I mean, every exploit allows you to check whether the exploit is applicable to a certain host or not. So you can check those kind of things here. You can even check what payloads are possible with this particular exploit. So one good thing about the Metasploit framework is it gives you a clear distinction between the payload and the exploit. So you can have a number of exploits and a number of payloads, and you can have a combination of those the way you want. It's not that all payloads won't work with every exploit, but then there are certain combinations which work together. I think it's something that you need to experiment with and find out. Okay, I'm not sure why is it taking a very long time, but yeah, we can come back to this a little later. Meanwhile, I have the MSF console here, which again gives you. So The difference between MSF CLI and MSF console is that MSF console gives you access to almost everything in the Metasploit framework. So MSF CLI is more of a lightweight command line interface, which just is useful when you're testing. If you do want to do some quick testing of your exploit, just edit it in say Vim or something, and then you want to test it out immediately. So you could use MSF CLI for that. So that's the thing. This one hasn't loaded till now. I'll go back to the presentation. So yeah, I mean, as you can see, like it provides options to check, list, and execute different payloads. And the good thing about MSF console is that it gives you a tabbed completion of the subcommands and options which are available with that. Even it gives you options to, I mean, on tabbing it also provides you exploits which are currently there in your Metasploit framework, which you can execute. So yeah, the last one, Metapreter, is more of a payload. What it does is it allows you to dynamically inject code into your victim system. So on Windows it uses DLL injection, and the good thing about that is it runs completely in memory, so you don't have any of your exploit artifacts littering around in this thing, like on the victim system. So it's very good when it comes to antivirus evasion and bypassing IDSs and things like that. So yeah, this is just a slide on what the Rex library provides you with. So you can see that there is a architecture library which provides you functions to dynamically generate assembly level instructions and all on the fly. So that's very good when you are targeting systems which are not the same architecture as your attacker system. So yeah, that's about the architecture library. Then there are some exploitation. Actually, you can have a look at these in the Metasploit documentation. It gives a very good explanation of each of them, and you can use them wherever you want to. As you can see, like they have some. I mean, these are things which you would really need for your exploits and all, like support for HTTP, almost all the protocols, network protocols that you would commonly find around, and things like that. So yeah, I was saying before that Metasploit also has support for port scanning, and you can in fact write your own scanner as well in Metasploit. It has got, I mean, there's a template which you can follow to write your own scanners. In fact, all these things go as modules, so they have predefined structures for each of these, and you can reuse them. So you have like, I think in my abstract for this I had mentioned that you could use Metasploit for information gathering and almost all the phases of penetration testing that you would have. So I think this is about that. Like, so the last one, if you see, like, it's not really it's more after you do your scanning and information gathering, and then when you're just before executing the exploit, that's when you run the check and see whether it is really, the versions are compatible and whether it is running fine, whether it's going to run fine. Yeah. So this is what, I mean, this is what you need to take care of when you're writing an exploit. There are general guidelines which you would follow whilst writing exploits, which you can find on most of the most of the websites. I mean, if you just do a Google search, you would come across them. But these are some things which are specific to the Metasploit framework. Like, I mean, you already have a framework which does most of the job for you, provides a lot of support for specific exploits and all. So try and offload as much as you can into the framework. Rex also has a lot of utilities which you can use. Mixins are used quite heavily. If we get time to look at some of the existing exploits and payloads, like you'll see, like almost each of them have at least 2 or 3 mixins which are used, and these are some of the ones which provide some functionality. Like the thing is that almost every exploit has almost every exploit that you would want to write has a specific pattern that you need to follow. Certain things are required in every exploit. Like if you're writing an exploit for a remote system, you always need to have support for TCP or any other remote protocol. So yeah, the last one is Rex provides you some randomization API where you can generate some random data to embed into your exploit. This is useful because you wouldn't want a certain antivirus to generate a signature for your exploit, and then it'll be a problem for you if you're trying another system, and if that system already has your signature in it, your exploit will get detected very easily. So randomization is a way to get around that. So yeah, that's about that. So this is how this is what the structure of a basic structure of an exploit is like. If you see, there's a there is a mixin used right here itself. But this is since this is very much stripped down, you wouldn't see the whole code. Initialize would contain your basic. It contains options for what your exploit needs, like certain specific port numbers. If your service is running on a different port number, this is where you can specify it. I mean, these are the default options, but you can also specify it when you're actually running the exploit. And some description. So this name, and you can also specify the description and all here, which is used by MSF CLI when it tries to list down certain exploits which you're looking for. Like, so Metasploit maintains a database of exploits, wherein in which you can search using the name. If you're looking for an exploit for, say, Nginx or for Rails, you can just search for Rails in that database, and it will give you all these exploits. This is where it picks it up from. And if you see, there's a section for payload as well, which is how Metasploit determines which payloads go with which exploits. So there is a certain amount of there are certain exploits which can go with certain payloads, and like there is a way to filter that out, and this is how you define that my exploits will. You can specify it here that your exploit will work with so and so payloads. And the most important part of this exploit is the exploit method itself, which is the actual code that you would run as a part of your exploit. You could do connect and put your payload into the system, into your remote system, and like Metasploit will take care of it from there on. Okay, I was talking about the check method. So as you have the exploit method, there is a check method also, which is there's something wrong with the fonts here. So it provides a check method which you can use to determine. So if you see, we are just checking for a specific version, and we are returning the code of code whether it is the system is vulnerable or not. So based on this, Metasploit determines whether a system is vulnerable for a specific exploit or not. Okay. So your payloads are written this way. If you see, there are two mixins for, there is usually a third one for TCP as well. The most important method here is the generate method, where you can provide some any code that you would want to inject into your remote system. So yeah. Okay, this is a, so there was a vulnerability in Rails, which was like about beginning of this year. So there is a the JSON parser which is available in Rails. Rails version 2.3 below 2.3.16 and Rails 3 below 3.0.20. So the parser, the JSON parser, it provides multiple backends where and one of those, like, you can I mean it converts the JSON to YAML, and then the YAML is passed. So there was a bug in the YAML parser which would allow you to exploit the system, which would allow you to create a remote shell, and we were going to have a look at this one. So so I have a VM here, which is on which I'm going to host the Rails app. It's just a dummy app. It doesn't have anything. It's just a skeleton app which I've generated. I think it's before that. Let me just show you. So this is the victim system that I have created as a VM on my system. I've named it victim only. So I'll just start the Rails server. And then let's look at the exploit here. So what I'm going to do is, so this is the command which I use to execute the MSF CLI utility to run this exploit. So like these rhost and rport, these are mostly provided by the mixins which you use in the exploit. So I'm just saying that my host is the remote host is victim, and the port on which it is running by default is 3000, and this is the payload which I am giving it. So it's a Ruby code. I know for sure that there is Ruby on that system because it is running Rails. So I'm using a Ruby shell here, and this is the option to ease to this thing. So if you see on top, I have a list of this is the help for MSF CLI, what options it provides and things like that. So in that, ease to execute and see if your host to exploit your host, and if you want to run the check method, it is the C. So let me just go ahead and run this. It usually takes quite some time to actually run the exploit, but once it is run, it gives you a shell to browse the system locally, and it also gives you the local user privileges on which the process is running. So yeah. Looks like it's going to take quite some time. Are there any questions so far? I mean, oh yeah, there. So there is, so since this vulnerability is available, I mean, is possible in Rails 2 as well as Rails 3, like you have to craft the exploit in different ways for Rails 2 and Rails 3. So it's like, so it will try for Rails 2 as well as Rails 3. Whichever one goes through, it will give you the session for that. So if you see, I'll just run a host name here. So I'm actually in the VM which has been exploited just now. I can do ls, and I can even create files here. I'll just do a touch for now. Okay, so the thing is, you won't really know from here whether it has been created or not. You'll have to go to this box and you'll have to find out. If you see, the Rails also has thrown a couple of errors here. Let me just log in. So we have this, it has created the file called exploited here. So basically what I'm trying to say is, like, you can I mean, you can do whatever you want once the system has been exploited. This is just one exploit, so there are many others possible. At the same time, when this JSON parser exploit was, the JSON YAML exploit was exposed, there was another one regarding the JSON XML this thing parser as well. So yeah, this is the code for the exploit. Now this is not code which is written by me. This is code which is already present in the Metasploit framework, and the Metasploit community, it keeps updating a lot of these exploits. I mean, based on what is available. I mean, what vulnerabilities are available. And based on that, they even many times you will have exploits which are written in some other language like PHP or C or something, which then get ported to the Metasploit framework exploits. So again, as I was telling earlier, like, there's quite some heavy use of mixins here. I mean, not in this particular case, but in exploits in general. Okay, I don't think there's any point in looking at this code like this. So basically, this is the yeah. So if, here they have one method for generating the YAML for Rails 2, and there's another one down which generates the YAML for Rails 3. So this is the malicious code which actually allows you to connect to the remote system via the shellcode. And this is for Rails 3, and if you look at your exploit code, it just this. You just do it for both the Rails 2 as well as Rails 3. You just post that JSON, and you can, I mean, you can get into the system. That's the exploit code. Then this is the payload that you send with it. Now here, like again, there is some use of mixins here. And this is the one which I was talking about. Like, you just, I mean, this is the code which you prepend there. Yeah, that's about it actually. If you look at the Metasploit framework directory where it is installed, you would see that there are a lot of modules which are provided. I don't know if this is visible, but yeah. This is the same thing which we saw in the architecture diagram of Metasploit. There are a lot of encoders available, a lot of exploits, and if you just scroll through it, like you can find exploits for almost anything that you have, anything that you would want to exploit, like, or if there aren't, you can always extend that. So that's all I have actually for today. And the references are, I mean, I relied a lot on existing tutorials on Metasploit, and yeah. So the Metasploit developers guide has got a lot of information about the architecture, what different components of Metasploit. Metasploit Unleashed is a very good tutorial on Metasploit by Offensive Security. They have other courses as well for lots to do in penetration testing and security in general. Rex documentation is where I was able to talk about the API, the Rex API from. An exploit database is where you can go and find out about exploits which are written by a lot of other people. So even if you don't know how to write your own exploits, you can rely on something which has been written by a lot of other people. You can plug it in with your own payloads and run it and see if it works for you. That's it.
Okay, thank you. Do we have any questions?
Yeah. Excellent presentation. One question is, which user will be, when you exploit it, after you exploit, you created a file, what is the user, what is the rule, user name? Is it
so
root?
In general, I mean, it could be any user, it depends on the exploit, but in this particular exploit that we ran, it is the user in which, under which the Rails process is running. Yeah,
right?
yeah.
And,
so if you have provided your, I mean, if you have put your Rails in a jailed environment, then you won't really, I mean, that way you can avoid some amount of, what do you call it, like some amount of destruction on your system.
have you heard of Brakeman, which helps us check the vulnerabilities in a particular Rails application? Does this work, does it counter any of the exploits which were measured in this?
I'm not sure actually. I mean, I haven't heard of that. That way, I'm not really a Ruby developer. So, I mean, I don't have much exposure to working on Rails.
There's a gem called Brakeman, which
okay,
if you want to check out your Rails application vulnerabilities, you can run a Brakeman and list out what all are open.
Brakeman, yeah. Brakeman, okay. I'll have a look at it. So, yeah, I mean, I'm not really aware of the, what do you call it, exploits specific to Rails or anything like that. I just generally like to look around for vulnerabilities and exploits in more widely used applications and things like that. So, yeah.
Have you tried the exploits on any popular libraries? Do you have any findings you can share with us?
Findings about?
Have you tried the exploits on any popular libraries, anything popular? And do you have like anything, any findings or anything you can share with us?
You mean public sites or
public sites or libraries or anything that is popular?
Not really. So most of these exploits, what happens is, like, you know, the more popular sites and all, they always try to keep a watch on security fixes. So now this one which I showed you, I had to actually make sure that I have that specific version of Rails and Rails installed on my on that virtual machine. So if I install the latest version, obviously these ones will be fixed. And there is something called as full disclosure, you know, for a vulnerability, which happens only after, you know, which usually happens after the vulnerability has been fixed. Like, so usually if you find a vulnerability and it is not really anywhere else, which you can't find anywhere else, then you have a very high chance of exploiting such systems. Otherwise, if you're going to go by some existing vulnerability database, then it's most of the times the case will be that the vulnerability will be already fixed. So you have, I mean, but then yeah, there are many times when you have certain websites which are not, which don't really which are not very keen on their security and all, and or rather they just don't bother much about it. Like, so these are your targets if you're looking for something like that. But
I mean, what I meant was like the having an exploit guide is something, those are like solved things. What I meant to ask you was, have you tried this to find something that is not found yet? That is, I mean, that is the whole point, right? I mean, what we are trying to do is see if there is something that is not discovered before.
Yeah. So I haven't really tried. I mean, I've tried, but then it's a very I mean, I don't really have any vulnerabilities that I have found out myself, and mostly it's been just reading up on all these vulnerability databases and things like that. So I feel it's more of a very lengthy process, and it involves a lot of trial and error. Like you have to, I mean, you just don't get it right at the first attempt or something like that. So yeah, that's about it.
Thanks.
Is it specific for only Rails application or any kind of application?
No, it's not. So your code is written in Ruby for the exploit, but it all depends on the payload that you send to your remote system. Now, in our case, I knew that there was a Rails app running there, so I could send a Ruby exploit. But then you could write the payloads itself in different languages. Like, in fact, the Metasploit database itself has some payloads which are written in Perl, some payloads which are written in C. So it's all about this thing. Like, I mean, the system on which the end system on which you are targeting.
And server operating system also will affect. Like, I am using Windows operating system or else Mac.
Okay, meaning to run Metasploit itself?
No, to attack and...
To attack. So to attack, it could be any system. So the database, the exploit database which is provided by Metasploit has exploits for Windows, different versions of Windows, has exploits for Linux, some exploits for Android. There are 2 exploits for Android phones as well. So there are, I mean, it's not just specific to an OS or something. And it doesn't make much sense to have, I mean, a framework just to target just one kind of a host. Like, yeah.
Any more questions?
Great presentation. Have they mentioned why they chose Ruby for their language? The exploits in?
No, I didn't really bother to find out about it. And yeah, I know it was written in Perl, if I'm not mistaken, earlier. And then I think there's this company, Rapid7, who took over the source code. I mean, and they, I'm not sure whether they are the ones who started writing it in Ruby or whether it was written in Ruby earlier. So the thing is, I'm not sure why it was written in Ruby. Yeah.
Thank you.
But one thing I see is that the mixins which are used in the exploits, right? I mean, I see that as a good this thing, like good thing. Like, I'm not sure how that would have been. It would have definitely been possible, but then it would have just made things a little difficult in other languages. Yeah.
Okay, so that's done, I think. Okay, a round of applause for Ausmarton.
Thank you.